Hello everyone, I'm Tejas, mentor for Team Mars Rover. Our project is Mars Rover Learning Kit inspired by real planetary rovers. The team built rover that can detect objects and navigate on its own, just like real rovers moving across the rough terrain. One of the biggest challenge was getting all the code work together. We had a lot of trial and error. At the same time, we had to ensure all the hardware components would fit perfectly inside the 3D model which we have designed. It's been incredible to watch their curiosity and ideas turn into working rover. I hope they perform well during the actual hackathon in front of jury and parents. Wishing them all the best. Best of luck, team.
Hello, my name is Rishikesh, mentor for all girls team. My team name is Aqua Innovators. My team members are Gianna, Brianna, Ketli and Avantika. Our project is called Seabottoms, the merchant ship learning kit. The idea behind this project was to help students understand how does a large ship operates, how does navigation system, crane system and engine system works together in a real time. One of our biggest challenges was to making a realistic 3D model of a ship and ensuring all the seamless connection between the hardware and software. Throughout the project, girls shows the incredible teamwork, creativity and curiosity. I'm really proud of what they have done and achieved all together. All the best for the hackathon.
Hello everyone, I'm Jagannath, mentor for Team Chromatics, comprising Arjun, Shiv and Daksh. Our project is the color object sorting robot, a robot that can detect and sort objects based on the color. What made this project exciting was the challenge of combining hardware and software, ensuring the color sensor gives accurate reading with the robotic arm moves with the perfect precision. The team has showed their relentless effort for the past 2 months in making this project a reality. I'm incredibly proud of their effort and confident that they will do well in the future, and I wish them all the very best for the hackathon. Thank you.
Hi everyone, I'm Tejas, mentor for the team Hexapod Legion with the teammates Jalvik, Madhav and Chinman. The idea was to build a 6-legged robot that moving using a tripod jet, just like how real insects walk. Getting the synchronization right between all 6 legs was one of the toughest challenges. It was required a deep understanding of the motion control, coding and all patience. But teamwork relentlessly to make the spider bot come alive. It's a fantastic display of a collaboration and innovation. I'm really proud of their hard work and wish them all the best to continue exploring the exciting world of robotics. Best of luck, team.
Okay, let's welcome our jury, Mr. Ashish. So, as you know, they both are going to come to your tables and you can discuss your projects. They might have some questions. I wish you all the very best. Let's start.
thank you very much for agreeing to spend this evening here. I think next 1.5 hours you're going to see what we've tried to achieve in last 4 months. So I think this batch started about April, May, June, when this 13 wonderful kids came here. A lot of excitement and curiosity and maybe don't know कि कर पाएंगे नहीं कर पाएंगे, course advanced है, simple है, but today I think you will see what they have achieved in last 4 months, and it has been a good journey, and probably most of you have not seen what happens right behind the scenes. So before we begin the formal presentations, I have a short clip to share with you. There are 4 teams, and one by one they'll come and present their project.
We are STEM empowered women. Now, imagine a ship sailing on dark, choppy waters of the ocean. It doesn't have any sensors and can't detect its surroundings. So, we were inspired by this situation to make a ship with sensors that can detect its surroundings and also has GPS.
There was a captain and he was on shore. It was stormy, the sea was rough. The radar system had just detected a large rock in the water, but thank God the radar system detected it and the ship was beeping loudly. Crew were able to get the ship out.
The wiring wizards of this merchant ship project were Gianna and Caitlin. The code captain who compiled all the codes together written by Gianna and Caitlin was Rihanna. I did 3D design of the merchant ship. This is a little circuit diagram of all the components of our merchant ship. This is the ESP32, which acts like a CPU. There are 2 DHT11s which check the temperature and humidity of the ship.
So on the 2 OLED displays, it shows the boot logo and basically it just shows the screen loading. Then it connects, the ESP32 connects to the Wi-Fi and starts a web server. Then in the main loop, the ESP32 reads all the sensors and it puts the readings of the sensors on our online dashboard and on the OLED display as well. The crane system which we built uses, so basically there are 2 servo motors and it moves manually, we can change it from the online dashboard, and it picks up these containers magnetically and drops them onto the ship. So this is the readings for the engine room. This is the AQI that we found with the gas sensor. It also senses the carbon dioxide and benzene in the room. This is the temperature of the engine room and this is the humidity of the engine. Thank you. So if you would...
Good evening, respected judges, mentors, and dear audiences. My name is Chinmay, and these are my teammates Javik and Madhav. Have you ever really stopped to watch a spider walk? The way it balances on 6 legs, the precision in every step, and the constant adaptability. We thought, what if we could bring this elegance to robotics? That thought gave birth to the Hexapod Spiderbot 6000. As you can see, each hexapod has 6 legs and each leg has 3 parts. These 3 parts are very important to the functioning of the hexapod. The first part is called the coxa, and the second part is called the femur, and the third part is called the tibia. The coding was very difficult, and our first prototype, and it was like the gate that the spider uses. It uses a tripod gate. We can customize the hexapod by adding sensors to the hexapod or by adding cameras. Because it is our own handmade project, we can also add a joystick and many other features.
Now let's see what's under the hood of our hexapod. So the hexapod consists of the legs and the body. The hexapod is a six-legged device that moves on electric power, and that it has 18 servo motors. Each servo motor acts as its muscle, and each servo motor is derived energy from the PCA's 9685s acting as the controllers. Now this controlling is controlled by the ESP32, which acts as a brain. Uh,
Have you ever wondered what's a Mars rover or what it is for? So a Mars rover is a machine that is used by space agencies or any other companies to launch it by rockets to other planets. Because we have interest in space exploration and research, then we have interest in technology and challenging ourselves. We wanted to learn advanced skills in real life project and understanding communication and for deep research. How we designed the robot. First designed the robot, then we assembled the parts, we made the PPT, and then we made the learning box, we joined all the hardware parts, then we debugged it, we tested it, and we touched.
So now these are the components of the rover. So to understand these better, you'll have to compare yourself to the rover. So you're able to walk with the help of your legs. So can a rover, but with the help of wheels. So now we have joints to help to move our body parts. So for that we have used motors and actuators in the rover so that it could locomote as well. And then as we have skeleton and skin on our body, the rover has chassis which is 3D printed with the help of a material known as PLA, polylactic acid. Then the power source is an 11.1 volt LiPo battery. And then the controller we have used is an ESP32. The software we use to do the coding is VS Code.
This is the MQ135, which is a gas sensor, and it senses the air quality. This is the Hall magnetic sensor. This is the LTAR, which detects whether there is light or not. This is the ultrasonic sensor. It detects the distance. And now we'll show you all the sensor values. So this right here is the DHT11, a temperature and humidity sensor. So the DHT11 is a slight bit slow, so it will take a while to increase the temperature and the humidity. And while that is happening, we can see the light dependent resistor, which is right here. Now it's seeing at low light level because of no light being present on the sensor right here.
Now imagine a world where machines have automated everything, sorting your waste, organizing materials, saving time, and also doing everything you can imagine. Now in this automated world, it's completely futuristic, right? Seems something will happen in the future. Well, the future is already here. So our color object sorting robot named Chromatics is gonna help you sort everything on the basis of their color. This is not the future, it is the future.
We faced many problems. There are many problems in the industries of agriculture, object sorting, and car building. Most problems, they are insufficient, they are slow, and they cost more. Our robots help them be more faster, more efficient, and at a larger scale. The smart color object sorting robot. First, an object is placed on the conveyor and the conveyor moves. The IR sensor detects the object, which then the color sensor, the TCS3200, detects the color of the object, and the signal goes to the ESP room 32, which then processes it and gives it to the Arduino. Then it gives the instruction to the robot, and then the robot picks up and places it in the right bin.
and the benefits of our project were automation. So in manufacturing factories and in agriculture use, normally people or the farmers and the laborers would have to sort suppose in a Lego factory they would have to sort the Lego pieces by hand. But with this, it becomes easier and more efficient. It also saves time and labor work, which reduces the cost for the factory. It saves much more time. Suppose if in an agricultural farm, if the farm is run by only one man, it's a startup. So he can't be wasting all his time on sorting the apples by if they're rotten, if they're green, if they're yellow, or they're red. So this can be used to sort all the apples. But this is just a prototype, so we'll have to work on it more to be able to sort fruits, Lego pieces fast. So our results and achievements. Successful automation. Robot sorts objects smoothly. So at first we could not sort them smoothly. Some of the objects were falling into the wrong boxes as we just saw, but this was due to the code being changed. Next is a proud moment. Our conveyor belt stopped perfectly on the sensor trigger. Before, the conveyor belt was not stopping exactly on the mark, and the object was a bit ahead or behind, which caused it to be not picked up properly. Next is our mentor feedback. We were praised the design and for the teamwork. When our team growth, we learned coding, electronics and collaboration. So we all gave our part in this, and it was a fun experience and we learned many things.
Thank you. We would like to thank all of our faculty, parents and my peer mates for helping me and making this project useful and automated.
Thank you.
First and foremost, thank you Rajesh for giving me this opportunity. I can tell you I came to know Rajesh because my son comes here and I had a semiconductor organization in Pune. So looking at the kids at this age, 7th, 8th and 9th grade, it's really fantastic, to see children getting engaged and have so much passion for both hardware and software. We have seen, at least when I was growing up, it was always a software driven ecosystem around me. So people would just categorize that you are in IT, right? Now people talk about semiconductors. So this is a great platform for all these kids to expose themselves to hardware, software, and the projects they are doing. I can tell you, we have hackathons in our organization globally in all the countries, and the projects would range more same or less like they do. Only thing is the efficiency and execution may be different. So I think kudos to Rajesh Shah and his team to making this so professionally driven and nice mentors for them. So thank you, and thanks everybody for encouraging your kids.
Hi everyone, my name is Sanat. This is my second time I've come here as a judge. I think last year there was the first cohort where I was a judge for the Hardware Hackathon. I'm very closely associated with Rajesh, so whenever something new comes up, I make it a point to come back. A bit of background on myself. I've been working into R&D for past 17-18 years, but in Singapore and Germany. And for quite a long time, I've been doing a lot of these R&D projects, hardware, etc. So my first few things, I would like to actually again thank Rajesh for introducing such curriculum, because you don't see that. I mean, you see that in schools and universities at the engineering level, even in Singapore and Germany. But introducing that at this level, between 5th standard to 10th standard, is really something. So again, thanks that you have the vision to take on that. Second, I'd like to thank all the parents over here that you are, want your kids to get exposed to such things which we ourselves used to do it in engineering, or even later once we had joined. So you don't see that anywhere else. I mean, even in Singapore and Germany, I don't see this at this level. We have courses, etc., but to do it in such details, it's quite something, and it's quite novel to this particular ecosystem over here. Third, I think the mentors, I would have to give you a vote of thanks as well, because there's a lot of effort that have gone, with different kids, with different characters and personalities. So when kids get exposed to these projects at this age, the amount of knowledge, information, I can't stress this enough. It's really mind-boggling that they are getting information, and with other communication skills, soft skills of those kinds. So I'm very happy to see novelty, students getting exposed to these projects, different sensors, different technologies, 3D printing, and so on and so forth, and at the same time enjoying and grasping them. I mean, at the end, we'll see at the awards as well. We have one special award called Parents' Choice Award. Okay, so imagine that ये चारों किट Amazon पे अवेलेबल है आज, तो आप आपका पैसा किस पे लगाओगे? ओके, नो पार्शियलिटी, नो बायस, बस उस नाम लिख सकते हैं, टीम नंबर लिख सकते हैं. So the object sorting robot, the ship, merchant ship, and the two projects, the Hexapod and Mars rover. So thank you once again. From next week, the kids will have an entirely different experience. It's the start of the software stage. So this is going to be completely different. So be ready for entire new experience. And it's not going to be easy, let me warn you right away. But if you are persistent, I think you will keep on doing better. So at 10x, what I say is, it's not always about being successful, right? I mean, they will learn more from failures and from strong feedback rather than, always getting the award. So I think today was a good sort of insight into where you stand. You've already done something which 99% of the kids don't do. So learning something of engineering level. So well done today. I'm very happy with the outcome, and we will continue the rest of the journey. And I think with that, I would like to thank all the parents for spending, like most of the events, we always run over time, and we'll plan better next time. But thank you thank you for your time, and I hope you liked all the projects.
Yes. Thank you for all the effort and to the